Hi, my name is Adrianna Schrader, and this is my article presentation for Systems Neuroscience. So this is the article at a glance with the publication info, citation. The title of it is fMRI of Intra-Subject Variability in ADHD, Anomalous Premotor Activity with Prefrontal Compensation. Now, I don't know about you, but that sounds really boring with that title, but I break it down going further on, so bear with me. So before we really get into it, there are three main buzzwords and some background information that you need for this. The population that's being studied is people with ADHD. ADHD is a neurodevelopmental disorder. Pop culture has it pretty well characterized, honestly. We tend to know the general characterization of inattention, executive dysfunction, hyperactivity, etc. We don't talk as much about the neuroscience of it, that it covers the entire brain. There's large discrepancies in frontal cortex, limbic system, and especially the motor systems. The main fact that you need to know about ADHD for this is that it's also associated with inhibitory dysfunction. Now, intrasubject variability is the next term, and it took me the entire article to operationalize this for myself, because it's differences between subjects within a category, but what does that even mean? It didn't make sense until I thought of these little targets as an example. So high intrasubject variability is you're kind of all over the place when you're trying to be consistently, your goal is to consistently hit this bullseye, right? So high intrasubject variability is that you're all over the place. Low intrasubject variability is your spread is small and you're a lot closer and there's less breadth here. Now, what we're going to do to measure intrasubject variability, they use response inhibition. And so response inhibition is the ability to repress and control actions in a given situation. And for motor actions, this includes response preparation and selection, and this occurs in the rostral supplementary motor area. So with that little bit of background, the purpose of the study might make a bit more sense. And the purpose is to examine the neural correlates of ISV during task performance, specifically a go, no-go task with motor response in children with ADHD compared to neurotypicals. And if you think back to the target, so who are we studying? People with ADHD. That tells you which target to look at. What are we studying? Intrasubject variability, which is how consistently can you hit that bullseye? What's your spread here? And then how the darts that you're throwing, it's response inhibition tasks. So you're tracking the breadth of the darts. And they have a hypothesis, and so their hypothesis was that for both go and no-go events, the relationship between ISV and premotor activation would be the same. So more premotor system activation, lower ISV. You'll be more accurate with that target. Secondly, in the inhibitory no-go condition for the ADHD kids, if they have lower ISV, then they're also going to have more prefrontal cortex activation than the neurotypicals, indicating that they're compensating for it. So for neurotypicals to change, for ADHD people to change their results from this to that, if they're doing it, the hypothesis is that they're doing it by having more activation in the prefrontal cortex instead. Now moving on to breaking down the methods a little bit. I'm just going into a little bit more depth about the participants. There was 25 children with ADHD, 25 typically developing children is how they referred to them, as a control to compare to. They're recruited from various places, all ages 8 to 13, no history of speech, language disorder, reading disability, and were all around the same kind of level of intelligence, and the ADHD was confirmed via parent interviews before this even went forward. And so what was the test? They had an fMRI cap on, electrodes and stuff, this specific one if you're curious, but they would sit in front of a screen. The test was about 5 minutes, and it would shoot rockets across the screen. So they would use their right index finger, push a button as quickly as possible when they saw a green one, and then don't do it when they saw a red one. And so green one is, yeah, that's the correct way to do the task, but the inhibitory response was actually whenever they didn't press for the red one. And then this led to a lot of analysis that gave a lot of different data pulled from this. So I'll admit the results were a little hard to digest. They were doing some hardcore analyses on this, but there were 4 main things that I really pulled from this, and this is how I understood them. So for typically developing children, when they had increased motor area activation, that rostral supplementary motor area, they would have more accuracy. They had that lower variability. But for ADHD people, whenever they had more motor area activation, the same motor area activation that they had, they would still be all over the place. And so that goes against the hypothesis. And so you'd actually see these opposite relationships. Positive feedback, negative feedback. And what was interesting, though, is whenever there was ADHD individuals with similar results, low ISV, to the neurotypicals, they would see that increased prefrontal cortex activation. But what's also fascinating is when they saw that same compensation in neurotypicals, it made them worse, and they had higher ISV. So it's an interesting opposition of reactions here. And another way to kind of think about this, neurotypicals, they're already operating at 100%, right? So they're already doing pretty solid here. But if they want to borrow 30% from the prefrontal cortex activation, now they're at 130, overclocking their system. It's putting too much strain on the system. You're thinking too much. But for ADHD people, they're operating at 70. So when you add 30 that you're borrowing from the prefrontal, all it's doing is bringing you up to par. So now you're on the same level as your peers. So as for main takeaways of this study, dysfunction of premotor systems in ADHD individuals does lead to increased variability and impaired response, but there are compensatory strategies that can overcome some of that deficit and improve results, bringing the ISV back down and more in line with their typical peers. As for the general commentary, it just increases the literature and support for understanding ADHD deficits in a holistic perspective. You need to understand how the systems interact rather than just identifying the deficit, because it seems like that would be the solution, right? So in this study, it was identified that less ADHD people had less activation in the motor systems cortex, but increasing that activation actually made a lot of it worse. And so it wasn't until you compensated with the prefrontal cortex that they were able to get on par with their neurotypical peers. And this was the opposite for neurotypicals. They couldn't use that same strategy without it throwing everything out of whack. And it just, in general, encourages the discovery of compensatory systems and the development of them for ADHD individuals. Thank you very much. This has been Adrianna Schrader for Systems Neuroscience.